Hi, I'm Anthony Hamilton, Product Engineering Manager for AAF International. Today, we're continuing our series on filtration terminology with a term I'm frequently asked about, dust holding capacity. Dust holding capacity is important because it directly impacts how long a filter lasts and how much your air handler costs to operate. In a previous video, we discussed how lower initial resistance reduces energy costs. Dust holding capacity, on the other hand, determines how that resistance will increase over time and how long a filter can operate before it needs to be changed. As air passes through a filter, dust and debris accumulate on the media. As this buildup increases, resistance to airflow also increases. Eventually, the filter reaches its recommended final pressure, typically between 1 and 1.5 inches of water gauge at rated airflow, at which time it should be replaced. Unlike initial resistance or efficiency ratings, dust holding capacity isn't one fixed number that you typically find on a datasheet. That's because it varies depending on the type and size of dust being captured. Large or sticky particles will clog a filter faster than dry, fine dust, for example. However, filters can be compared under controlled conditions using the ASHRAE 52.2 test method. This test measures how filters perform when exposed to the same mix of dust under the same conditions. Let's look at how that works. In a dust holding capacity test, dust is fed to the filter in controlled increments, typically 30 grams at a time. In many real-world applications, 20 to 30 grams represents about 1 month of dust accumulation, so you can think of each increment as roughly a month of filter life. The test begins by recording the initial resistance of a clean filter. As more dust is applied, the resistance increases. At some point, the filter reaches the manufacturer's recommended changeout pressure, often around 1 inch of water gauge. After this point, resistance usually increases much more rapidly. That means higher energy usage as the fan works harder to move the air through the loaded filter. Let's compare pleated filters as an example. Pleated filters are often sold as standard capacity or high capacity, and in some cases there are premium pleated filters available. The key difference is how much dust they can hold before reaching final resistance. A 2-inch deep standard capacity pleated filter might reach 1 inch of water gauge after holding somewhere around 60 grams of dust. In many environments, that represents around 2 to 3 months of operation. A high-capacity version, with additional media surface area, might reach the same pressure at around 90 or more grams of dust, extending filter life by an additional month or more. A premium pleated filter, however, may not reach 1 inch of water gauge until it's held over 200 grams of dust. That could translate to 6 or 9 months or even a full year before changeout, depending on conditions. So, what drives higher dust holding capacity? There are 3 primary design factors. First, media surface area. More pleats means more surface area, which allows the filter to capture more dust before the resistance begins to significantly increase. Second, media construction. Graduated or dual density medias allow more particles to load throughout the depth of the filter, rather than just on the surface of the media. This improves loading characteristics and extends life. Third, structural support. Stronger backing materials help maintain even pleat spacing and prevent uneven dust loading, which can prematurely increase resistance. Now, you may notice that some higher capacity filters may have slightly higher initial resistance. That can mean marginally higher energy use when the filter is brand new. But filters are perfectly clean only very briefly in real-world operation. Because higher capacity filters load more gradually, they offset that small initial difference very quickly. When you look at performance over time, the differences become clear. For example, a standard filter that reaches changeout pressure every 3 months would require 4 replacements every year. A premium filter lasting 6 to 12 months may only require 1 or 2 replacements, therefore, in that same period. Fewer changeouts mean lower labor costs, fewer disruptions to operations, and reduced waste, in addition to potential energy savings. Some manufacturers provide total cost of ownership calculators that factor in filter price, energy consumption, and service life. When you evaluate all those costs together, higher capacity or premium filters often provide significant long-term savings, even if the upfront cost per filter is a bit higher. So to recap, dust holding capacity determines how long a filter lasts before it should be replaced. Higher dust holding capacity means longer life, fewer changeouts, and often lower total cost of ownership. When comparing filters, review the ASHRAE 522 test results, consider both initial resistance and dust holding performance, and evaluate total operating costs, not just the purchase price. At American Air Filter, we're bringing clean air to life. Please don't hesitate to reach out if we can help you in any way.